All right, Chem students, in this video we're going to talk about periodic trends. So it's best to have a sheet of paper, something to write with, some highlighters to take notes with. Remember, I don't expect you to take notes over every single word on every slide, just the most important parts. In this video, we're going to talk about trends that you can find using the periodic table. The first trend is atomic radius, which is basically the size of the atom. As you go down a group, the atomic radius increases. That is because you're adding energy levels to the atom. If you look, lithium has 2 energy levels while francium has 7. So the atom is going to be larger. As you go across the period, though, the atomic radius decreases. As more protons are added to the nucleus, the stronger pull it has on the electron cloud. So think of the nucleus as like a strong magnet, and the more protons that you add, the closer it's going to pull the electron cloud to it. Ionic radius has the same trends for the same reasons. We have 2 types of ions on the periodic table. We have positive or cations. The positive ion is always going to be smaller than the neutral atom itself. That is because when an ion becomes positively, or when an atom becomes positively charged, it loses its valence shell, thus becoming smaller. Negative ions are going to be larger because now you have extra electrons and they're able to pull away from that electron or from that nucleus. Ionization energy is electron losing. It is the measure of the energy required to remove an electron from the outermost energy level. As you go down a group, the trend is that it decreases, and that is due to the shielding effect, and we'll discuss that on the next slide. As you go across, you have the nuclear charge, which is increasing, and this supports the theory and the idea that metals like to lose their electrons. The energy required to remove an electron from atoms on this side of the periodic table is a lot less than it takes to required to remove an electron from this side of the table, which are nonmetals. The shielding effect is that an electron in the outer energy level of a large atom is easier to remove because it is well shielded from the pull of the nucleus by the inner shell electrons. So let's take these 2 atoms here. We have lithium, which has 2 energy levels and 1 valence electron. You see that this valence electron is very close to the nucleus. Think of the nucleus as mama, and this electron is the baby buffalo. It's pretty close, so it's going to be difficult to steal it from that atom. If we look at rubidium, there are 4 energy levels to shield this one baby buffalo from mama. So this is going to make it much easier or less energetic to steal the electron. Electronegativity is how well can the atom attract electrons. Now remember, metals don't like to attract electrons, they want to give them away. Nonmetals want to gain electrons. The noble gases have 0 electronegativity. That is something you want to write down. As you go down the group, it decreases once again due to the shielding effect. The nucleus is what holds electrons in that electron cloud. The positive nucleus attracts the negative electrons. So the larger the atom gets, the further away its electrons are from the nucleus. So it becomes harder to attract electrons. As you go across, remember that nucleus is adding protons which attract more electrons. This once again supports the idea that metals like to lose electrons and nonmetals like to gain. Those are the trends that we will discuss in class. Let me know if you have any questions.